That looks cool. I should go there.
Printing is hard. 3D printing concrete, well, that's even harder. And 3D printing a concrete bridge, well, that's really quite a difficult challenge. And to understand why, you need to know a little bit about how concrete actually works. Concrete is incredibly strong in compression. You can stack enormous amounts of weight on it and it holds up fine. That's why we use it for things like foundations. But if you try to pull it apart or bend it, it's actually quite weak. Concrete is about 10 times weaker in tension than it is in compression. The way we normally deal with this is by putting steel reinforcement called rebar inside of the concrete. The rebar deals with the tension and the concrete deals with the compression. Together, they make one very strong bridge. A concrete 3D printer works by extruding concrete layer by layer, kind of like squeezing a giant tube of toothpaste. Building with concrete normally, you'd build a mold, put the rebar cage inside it, and then pour the concrete to fill the mold. With 3D printing, there is no mold, so there's no easy way to add the rebar mid-print. And it gets worse. These layers introduce new weaknesses. Concrete that's been printed this way isn't as strong as concrete that's been poured out all at once. So now you've got a material that was already bad in tension, and you've introduced new weaknesses into it. On top of all that, the mortar you use isn't the same as standard concrete. It needs to be liquid enough to pass through the nozzle, yet firm enough that when it does, it instantly holds its shape. That's a totally different mix than what building codes are written for. They don't have a chapter on 3D printing structures. There are no guides for this. And yet, in October 2017, a team led by TU Eindhoven put the world's first concrete 3D printed bicycle bridge right here in Gemert, in the Dutch province of North Brabant.
The way they solved the reinforcement problem was clever. Instead of trying to get the rebar into the print, they designed the bridge to be pre-stressed. They printed the bridge in separate elements, 8 sections, each about 1 meter long, with hollow channels running through them. After printing, they threaded high-strength steel cables through those channels and pulled them tight, putting the entire bridge into compression. If the whole thing is already being squeezed together, it takes a lot more force before any part goes into tension. The printing itself happened off-site at TU Eindhoven's lab, using a special mortar, after which the 8 sections were assembled and installed on-site here. The bridge is 8 meters long, 3.5 meters wide, and was tested to carry loads of up to 2 tons. Today, hundreds of cyclists cross it every day. So with all of these challenges, why would we even want to 3D print a bridge instead of doing it the old-fashioned way? Well, first, material savings. A 3D printer only deposits concrete where it's structurally needed. No formwork means no waste from molds that get used once and thrown away. That can mean up to 50% less concrete compared to traditional build. Second, speed. Once you have a design and a printer calibrated, printing can be significantly faster than traditional construction. Third, lower CO2 emissions. Less concrete means less cement, and cement production is one of the biggest industrial sources of carbon dioxide. Any reduction makes a meaningful difference. Finally, and this is the most exciting reason to me, design freedom. When you pour concrete into a mold, you're limited by the shapes you can actually build a mold for. Straight lines and simple curves are easiest and cheapest. But a printer doesn't care. It can follow any path you program into it. You can make organic shapes, varying thicknesses, curves that would be absurdly expensive to form traditionally. Now, this bridge here in Gemert, it's a proof of concept. It's straight, it's functional, it does the job. But it doesn't exactly scream design freedom. But there is another bridge near here that does.
So the bus I want to take is 38 minutes delayed. So I could have probably just finished the video there, but video will do. I don't feel like going back now. I just got off what is possibly the hottest bus I've ever been on. I'm in Nijmegen, still in Holland, but now in the province of Gelderland, and the bridge behind me takes more advantage of the design freedom 3D printing allows you. It looks like something that grew here, rather than something that was built. That's because for this bridge, the architect had complete creative freedom. In 2018, Nijmegen was named the European Green Capital, and Rijkswaterstaat, that's the Dutch government agency responsible for public infrastructure, wanted to donate a special bridge to mark the occasion. They chose 3D printing specifically because of the design freedom it offers. The designer could design shapes that would have been either impossible or absurdly expensive with traditional formwork. You can see how they were able to vary the bridge's width and thickness along its length, making it absorb forces differently at different points, rather than just being a uniform slab. At 29 meters long, when it opened on the 8th of September 2021, it was the longest 3D printed concrete bridge in the world. In total, the bridge required 120 metric tons of mortar and about 57 kilometers of print path. All in all, it took over 160 hours to print. But here's the thing. The Gemert bridge was built in 2017, so it's been nearly a decade since the technique was first used. And yet, in total, there are maybe a dozen 3D printed concrete bridges in the entire world. A couple in China, one in Spain, a few others scattered around the rest of the world. The advantages I listed earlier, they're real, but so are the problems. There are still no widely adopted design codes for 3D printed concrete structures. In Europe, standardization efforts are ongoing but incomplete. In the US, the first proper standard only reached finalization in 2025. And for most bridges, the honest truth is that traditional pour is still much cheaper and much faster. So these two bridges are impressive, but they might stay rare for the foreseeable future. Not because the engineering doesn't work, it clearly does, I'm standing on it, but because without established standards, every project like this needs years of custom testing and approval before a single layer of concrete gets printed. And that makes it very hard to compete with a technique we've been using for over a century. So for now, maybe the most impressive part is that this is just a bridge. People don't care how it was made. The important thing is that you can bike over it on your commute.